Welcome to the video for Lecture 15, Section 3. This video will cover several practical measurement issues that need to be overcome when using thermocouples. Many of these issues apply to other sensors and transducers. I am using thermocouples to give a physical meaning, but you are strongly encouraged to remember that these issues apply to other sensors too. We have talked about noise before. This slide tries to show how noise is part of an electronic signal, and that noise can make it difficult to find the signal. Noise can be generated or picked up from other electrical equipment in the area or power lines that are near wires connecting sensors to data acquisition equipment. It is important to understand that it is difficult to eliminate noise. So noise needs to be anticipated and managed. So let's talk about managing noise picked up when using thermocouples. Remember that thermocouples generate small electromotive force voltages. If you look at the voltage ranges for the Type T thermocouples in Table 16.2 in the course packet, you can see that across the temperature range from minus 200 degrees Celsius to 400 degrees Celsius, the voltages range from minus 5.6 millivolts to plus 20.9 millivolts. And around 0 degrees Celsius, the voltage will be 0 millivolts. Small temperature changes will produce small EMF changes, so it is hard to find a small EMF if there is a lot of noise. Another major source of error comes from induced voltages from power lines and other electronic equipment near where thermocouples wire goes. Induced voltage in thermocouples and other sensor lines is not desirable. There are some short thermocouples just a few inches long. In some applications, thermocouple wires can run thousands of feet. Two options for managing induced voltage include using guarding or shielding. Shielding is done by buying thermocouple wire with a shield surrounding the thermocouple wires. The figure in the upper right corner has a silver-colored metal foil that surrounds the 5 signal wires. This figure does not show thermocouple wire. The shield intercepts the induced voltage and drains it away by being grounded. So the foil shields the signal wires from induced voltages. It is important to remember that shielded wires should be grounded at only one end. It is usually recommended, if possible, to ground the wires at the recording device. The other method for managing noise, especially 60 cycle noise from power lines in the US and 50 cycle in Europe, is to use a filter. Filters can mitigate noise, especially 50 and 60 cycle noise. We will talk about filters near the end of the class. Another practical thermal sensor measurement issue is thermal shunting. Thermal shunting occurs when the sensor being used is larger than the thing being measured. Thermal shunting means that the sensor is too big so that the sensor alters the thing being measured. One example might be if you were trying to measure the temperature of an insect, and you were using a large thermocouple that is larger than the insect. Are you really measuring the insect temperature? Probably not. One way to try to mitigate thermal shunting is to use extremely small thermocouple wire and small junctions. While thermal shunting deals with temperature measurements, the issue of a large sensor impacting whatever is being measured is an instrumentation concern to keep in the back of your mind. Another practical temperature measurement issue is related to conduction errors. Conduction errors occur when a temperature sensor crosses a hot zone and a cold zone. If the measurement device conducts heat, the thermocouple wire and many other temperature sensors do conduct heat, and the heat conducted will cause errors in the temperature measurement. The heat will raise the sensor temperature a bit, or the cold will cool the sensor a bit. The two ways to mitigate conduction errors are to insulate the pipe or duct to reduce heat exchange, or to have a wire run parallel to the duct so that the wire gets warmed along the duct. These are issues when very precise temperature measurements are required. The next temperature measurement issue is radiation effects. Radiant heat transfer can cause temperature measurement errors. The classic example is measuring air temperature outside. Solar radiation from the sun during daylight hours can distort the temperature reading if the sensor is not shielded. The same thing can happen at night on a clear night due to radiant cooling. Another example can occur when placing thermostats in a house. Thermostat should be located on an interior wall out of any sunlight. Radiation effects can be mitigated by installing the temperature sensor inside a radiation shield. The figure here shows a radiation shield commonly used when measuring ambient temperatures. The radiation shield allows airflow past the sensors, and the white color reduces radiation effect. Another thermocouple measurement issue can be caused by thermocouple wire decalibration. Wire decalibration occurs when thermocouple wire is unintentionally altered in some way. Wires can be altered by stretching, which makes the wire thinner. Wires can also be contaminated if the wires go through a corrosive or contaminated environment. Thermocouple wire decalibration can be mitigated by protecting wires that go through a corrosive or contaminated space. The other key thing to do is use care when installing thermocouple wires. This concept applies to other signal wires. Be careful when installing them and protect them when go into a corrosive or contaminated space. Another measurement problems can be insulation breakdown with thermocouple wires and signal wires. If the insulation breaks because of heat damage or mechanical damage, the wires can touch each other and create new junctions. And hopefully you remember that thermocouple wire junctions of these similar metals will create an EMF dependent on the temperature of the junction. So, if you have thermocouple wire that has extra junctions in uncontrolled areas, you will get erroneous readings. The best way to mitigate this is to use care during installation. This would be considered a bias or systematic error that would be hard to find, but careful calibration might help indicate that you have some extra uncontrolled junctions. The final two potential thermocouple measurement issues are listed here. If you must use very thin thermocouple wires, you must be careful to avoid damaging the wires. You might use these very thin wires if you are trying to manage thermal shunting. Finally, the last problem is a poor junction connection. You need a solid junction between the two dissimilar metals to produce the EMF. This can be mitigated by soldering or welding. This brings me to the end of Lecture 15, Section 3 video. The next video will cover resistance temperature detectors, commonly called RTDs, thermistors, and integrated thermal transducers. Please write down any questions you have and bring them up in class or lab. Thank you.